sometimes we don't get the expected ratios that we determine that we should get given a cross. And when that's the case, that helps us determine that there might be something else going on than the straightforward Mendelian dominant recessive traits that we've been talking about with that specific pattern of inheritance. One of the things that might cause unusual patterns from what you actually observe, from what you expect to get given your Punnett squares, is that of lethal alleles. So let's take a look at this example. Here, it was observed that there were unusual patterns when studying coat color in mice. After mating 2 yellow mice, they were unable to get a normal 3:1 phenotypic ratio of the dominant to recessive phenotypes. They ended up getting a 2:1 ratio with 2 yellow mice for every 1 white mouse. They found that the yellow mice were all heterozygotes. What appeared to be a non-Mendelian ratio was caused by a lethal gene. And so what we have here is an example where the combination of big Y means that that is a lethal allele combination, and that individual will never be born. And so what you end up seeing is very different ratios from what you expect. Let's take a look at a real problem that you have in your problem set. So we've got, let's say that in chipmunks, the gene for tail length has 2 alleles, big C, little c. In heterozygotes, big C, little c, short tails are produced. So we know that this is going to equal short tail. In homozygotes, little c produces normal length. So little c is going to be normal. Big C is going to be lethal. That is, the embryo is not even going to be born. All right. So a nub male, so that's a short-tailed male, is mated to a normal female. So we actually know what those genotypes are. If you are a nub male, you're going to have big C, little c. And if you are a normal female, you're going to have little c, little c. What will be the resulting phenotypes and probabilities of their living offspring? So we can create our Punnett square and we can fill it in. Big C, little c, little c, little c, big C, little c, little c, little c. And so what we see here is that we're going to have half of them that are going to be nub or short-tailed right here. And the other half is going to be normal tail. All right, let's go down to part B. If 2 nubs are mated, what will be the resulting phenotypes and probabilities of their living offspring? So here we know that you have an individual with big C, little c, and an individual with big C, little c mating. So let's fill out our Punnett square. Big C, big C, big C, little c, big C, little c, little c, little c. Now we know that the CC combination is lethal. We are never going to see those offspring. So what we get is that 1/3, 1 out of the 3 possibilities that are going to be born, is going to have a normal tail. And 2/3, 2 out of the 3 possible combinations that are possibilities that are going to be born are going to be nub.